Alright, so here's the YouTube. This is the dynamics problem. Find the angular velocity using polar coordinates. I will put the description in the link below. But here we go. We're gonna solve this my way. Oh hell yeah, this is easy money. We're one and done. We're just gonna go for it. I don't know the answer to this problem. I just pulled it off the internet. It's got a whole YouTube, so you do you. But it says at the angle of 45 degrees, you got a runner running that way at a speed. 2 meters per second, just double it. That's 5 miles per hour. Hell yeah. Well, plus 25%. Man, that don't work. So what's 25% of 2? Well, what's 10% of 2? Well, 0.2 miles per hour, plus another 0.2 miles per hour, plus another point, you know what I mean? So yeah, this is 5.5 miles per hour. Okay, yeah, it's probably running pretty slow. I don't know. Yeah, he's just jogging. Oh, this is a dumb problem. Okay, but anyway, he's running. And check this out. It looks like we're doing a curved problem. Hell no, it's just a picture. It's so stupid. But anyway, he's just running a straight line. And it says this angle. You know what I mean? If I throw this camera, it says determine the angular velocity at which the camera must turn in order to follow the motion. Well, this is a dumb problem too, because if this runner's way the hell over there, you know what I mean, you're not going to have to turn the camera much at all. You know what I mean? Like, oh, I'm just going to slowly move the camera to right there. But then once he's like right here, well, you better like move the camera real fast. You know what I mean? But at a 45, okay, you know what I mean? I think we get it. But that's crazy. You're not going to rotate the camera. If this runner's going around a circle like that, then yes. You know what I mean? So yes, if you're just going around a circle, so let's just do that one. The whole idea is just to do a problem where, okay, so this is a distance of 30 meters. This is so dumb because this is 30 meters. Well, let's just call this 30 meters. You know what I mean? Perfect. So if that's 30 meters, and what's the distance of a circle? You know what I mean? Well, it's 3 times 30. You know what I mean? So that's 90. So this whole circle is just 90 meters. You know what I mean? We're totally guessing. Pi is equal to 3, not 3.14. That's nutty. Okay, but anyway. So, and now the runner's only going 2 meters per second. How long is it going to take him to go around the friggin' circle? You know what I mean? It's going to take him, well, half this. So 45 seconds. Okay, that ain't bad. Okay, so you're going to have to do a whole 360 degrees in 45 seconds. You know what I mean? So I think we got our answer. Determine the angular velocity at which the camera must turn. Well, you know, you're going to turn real slow. You're going to do a 360. You're just going to stand there for 45 seconds, and by the time 45 seconds goes around, you're going to be just doing a circle. But this runner's not doing a track. It's just saying at this instant. So if at this instant, well, now we're doing the trick of the trade. You know what I mean? Trickety trick. It's saying we'll do this. You know, if you want the actual answer to this problem, well, you say, hey, instantaneously, this angle's 45. Now check this out. In 0.1 second. So this is time is equal to 0. We're just going to say 0 time. How about time is equal to 0.1 second? You know what I mean? You could do 1 second, but you're going to get like a real sloppy answer. Well, let's just do 1 second, and then we'll come back for the good. Okay, so if we do 1 second, well, the guy's going to go 2 meters. Holy Toledo. So this is like 2 meters. You know what I mean? He's going to run 2 meters, so he's going to go there to there. So anyway, and now let's just go back to guess, because we said this was 90 meters, and he's going 2 meters of 90. So 2 meters divided by 90 meters, well, we need the calculator for that. 2 divided by 90, you know what I mean, times 100. Well, that's 2.2% of 360, or just 0.02 divided by 90 times 360. Hell, it's going 8 degrees. You know what I mean? So I would say 8 degrees a second. So now we got our first guess. We need to, the camera needs to move 8 degrees per second. But no one uses degrees, they use gosh darn radians. You know what I mean? And I know, anyway. Radians per second. Well, what the hell is a radian? Well, just like pi is 3. Burn it into your brain that pi is 3. Burn it into your brain that a full circle, well, that's just 6 radians.
Now it's 6.28. Well, where the hell did you get that? Well, 3.14 plus 3.14, and that's pi plus pi. Yeah, because a half a circle, well, that's pi, and then pi. So we got 2 pi radians is equal to 6.28. You know, kind of a guesstimation. But anyway, 6 radians. Just call it what it is. So anyway, if we take 360 divided by 6, well, hell, don't we get 60? Hell yeah, so 1 radian is equal to 60 degrees. And if I only got 8 degrees, well, now I got to take 8 divided by 60. 8 divided by 60, holy Toledo. So that's only like a tenth of a radian. That's a 0.13 of a radian. So we have to go 0.13 radians per second. I'd say final answer, final answer. But now if you want the exactamundo answer, man, this is what you do. Well, now you got to draw your friggin' thing good. Because you got to go 45, and you got to go, this is 30. And then the runner's running a straight line this way. And we're just going to go, so this is t0, and then we're just going to go a tenth of a second. So in a tenth of a second, the runner's only going to go 0.2 meters. So we got 0.2 meters is this little slice, and he's just running in a straight line. So now we have to find this angle. And that looks real tough. That looks something like I don't want to do. But what do we know? What do we know? Well, we know that this is 30 meters, and we know that, I'm just going to, if you have the angle here and there's something over there, hey, it's the sunshine and signing, you know what I mean? Hey, it's rising. I don't know the song. I've just made that up. But anyway, see how this is like the sunshine is shining on the sign? I don't know, but this is the cosine. That's like the hoodlum. You know what I mean? Behind the alley, adjacent. You know what I mean? This is adjacent. That is just the person across the. You know what I mean? Doing it. Okay, so this is across. This is opposite. Probably opposite of what you want to be. You know what I mean? You want to be this cosine, the cool kid. I don't know. I'm just reliving my childhood, but I think we're just trying to find ways to. Just, hey, shine it up with sine, and then cosine is just, you know what I mean? I got picked on. Okay, so cosine. Anyway, so I think we got it. But yeah. So, but if we go, we can find this. We can find this length because that length, we'll just call it h. H1. I don't know. This is getting crazy. But H1. Sine 45, well, that's equal to 30 meters. So you can go H1 is equal to just 30 meters divided by sine 45. And that's 30 divided by 007, 707. You know what I mean? You can just do this in your head if you know it. So sine 45.707. So we go 30 divided by 0.707. Hey, I'm doing really good on this problem. I'm loving this problem. So we're just going to... Okay, well we got 20 more minutes on the clock. Hell yeah, we're just we don't want to lose anything here. We don't want to lose anything. This is amazing. Okay, so now we got that H1, and I guess we're just gonna call it H. You know what I mean? And so we got what the hell? Okay, and then we're gonna store that as H. Okay, now we got it. So we got 42.43, and that's H. I don't know if this gets us any closer at all. But essentially we need to find that really ridiculous angle. And if we find this angle, we know it took 0.1 seconds to go do this angle. Do that angle. You know what I mean? Ooh, I just use that as the angle. I don't like this as an angle. That means I'm going to get a D in this class. A C minus. A C plus maybe. So I like this. And I just use everything that way. Anyway. I just don't want to confuse you. Okay, but it says angular velocity. Well, that's just angles per second. And so we're going to figure out what this angle is. I bet you it's like a degree. No, but we need to figure it out in radians. Well, we already figured it out. It's like a tenth of a radian per second. Okay. Oh, damn it. So yeah, the degrees is going to be 8 degrees, but you got to divide by 60. you know, or 57.29 or something like that radians per second. Anyway, but we're trying to use trigonometry to actually find this angle. Now, can we do it? Oh, check this out. If this is 2 degrees, there you go. So, now we need to find the cosine. Okay, perfect. So we know, I don't even think we needed that h. We just needed to find, now we need to put letters on our calculator. We're going to do this as j. Okay, so if we take, oh, and then you use tangent. Tangent is opposite over adjacent. So we know what that is. So we go tangent of 45 is equal to opposite 30 divided by j. And now we can just, j is equal to 30 divided by tan 45. Okay, so 30 divided by tan 45. And, oh, damn it, that's 32. Well, duh, it's a 45-degree angle. Man, that's all right. We'll still store it as j, so we don't get confused. Okay, but that does mean that now look at this. But now our j, we're going to call this one a new letter. We're going to call this one k. K is just j minus 0.2 meters. Okay, so k is equal to j, 30, minus 0.2 meters. Well, that's 29.8 meters. Yeah, hell yeah, that's k right there. And, ooh, bummer. So we need to know one more. Oh, we still need to know, oh, this didn't change. Perfect. And then we go tangent of our new friggin' angle, and we'll just call it, you know, angle 2. Okay, because I don't like to use, like, phi. We're using theta as angles, baby. Okay, that's going to be opposite, so that's 30 over adjacent, k. Hell yeah. But how do we get the angle? Well, you just take the inverse tangent of that, and then inverse tangent of 30 over k. So technically, all you have to do is just take the tangent inverse. But inverse tangent of tangent, hey, that just gets rid of these tangents. And I think that's a secret sauce right there. It makes sense if you know that. But anyway, now you just got theta is equal to inverse tangent of 30 over k. What the hell's k? K is 30 minus 0.2, or j minus 0.2, and then store that as k. And then we got inverse tangent. Oh, dang it. Inverse tangent of j over k, which is just, okay, I think we get it. And when we get our angle, our new angle is 45.1916. Now our change in angle, you know what I mean? Our change in angle, because angular velocity is in radians, which is change in the angle divided by change in time. Just like velocity is equal to change in position divided by change in time. And you've seen me do this in other videos, that acceleration is just change in velocity divided by change in time. Now you're going to get an average. You're going to get an average velocity, you know what I mean? But we're taking such a small little snippet of time, 0.1 seconds, that check this out. So now our change in theta, all right, so final answer. Change in theta, change in time. Change in theta is equal to 45.19162397 minus 45 degrees divided by 0.1 seconds. And I think you get it. So minus divided by 0.1. And booyah. Now we're at 1.9 radians per second. No, 1.9 degrees per second. Dang it. So this was changing angles in degree. This is not, this is what you want radians. So if this is degrees, but now we got, now what do you get? Well, you got 360 divided by 2 pi radians, which is 360 divided by 6.28. For the more accurate answer, you know, it's just 360 divided by 6, but it's 360 divided by 0.628, and actually it's 360 divided by 2 pi. We'll just do that, 360 divided by, but see how confusing that is? It's just 360 divided by 6. You know, who cares about those 3 degrees? But I guess we do. We're going to store that as p. And then now we're going to take that 1.9, which we did not save. Minus 45 divided by 0.1. We're going to store that as Q. So now we're going to take alpha Q divided by alpha P. So we're going to take this 1.9 degrees divided by, and we get 0.033 radians per second. So isn't that interesting? That our change in angle, so our guess was real crappy. That's all I'm getting at. It made no sense because it said if you have a 30 meter. That's where I was wrong. It's pi is 3. Yeah, that's if you're using diameter. So my guess was absolutely horrible. We need to divide this by 2 and we get 0.065. And we're still just crap guess. I don't know why. I don't. Yeah, 0.2 meters. We got that. And we did 1/10 of a second. So we went 0.2 meters in 1/10 of a second. I'd say this is a pretty good answer. So it's going to be 1.9 degrees per second or 0.033 radians per second. But we gotta double check because our guess was just god awful. Alright, so put some more time on the clock. And I don't got anywhere to write. But let's say I just had to do a 2-second guess. Okay, so if this is 30 meters and we just draw a circle, then the circumference of the circle is 2 pi r. So this is 30, this is 2, and pi is 3. So we basically got 2 times 3 is 6 times 30 is 180. So we have 180 meters, and we're saying in 1 second, this person can run 2 meters. Okay, so we got 2 divided by 180, 2 divided by 180. And now we multiply that by 360, and we get 4 degrees. So based on this, that runner. And that's so interesting. It's because this is 30 degrees and this is 30 degrees, but this distance is not. So our guess was based on the runner being right there. But if the runner's over here, then this is 30 squared plus, this is the other equation to know. You know what I mean? If this is 45 degree and this is 30 and this is 30, what's this length? I mean, you have to know this in engineering, is that this plus this, you know what I mean? This component plus this component, well, you got to go 30 squared plus 30 squared and square root all that, because if you're saying this is h, well, Pythagorean's theorem, 30 squared plus 30 squared equals h squared, but we just want to know what h is, and it's just 30 squared plus 30 squared, square root of all that. And yes, we get 42. We're just going to store that as x, because that was our huge mistake just on guessing. And we won't guess no more. So we're going to take 42.2 times pi times 2. So we're going to go times pi times 2. So this was interesting. This is where guessing didn't get us the right answer, but it's actually helping us check our answer. Yeah, so it's not, this circle isn't 180 meters. It's 266. So now our runner at 45 degrees, he's pretending like he's running in a 266 meter circle. Well, that's divided by 2. That's going to take him 133 minutes. You know what I mean? 133 seconds. So, yeah, it's going to be real slow. So that's how many, 133.2 seconds and 360 degrees. So that's the answer. That's the answer right there. Or in radians, it's going to take 6.28 radians in a circle, and that's going to take 133.2 seconds. So let's do this one. 360 degrees divided by... Oh, we got to store that as t for the time. So 360 divided by the time. Well, yeah, now we're at 2.7 degrees. And our actual answer is 1.7. So even still, we're doing a poor job of guessing. And I think we made a mistake. I don't think we made a mistake. we're gonna go to the internet and find the actual answer. And I'm gonna laugh at this one because I'm learning, but I make tons of mistakes. It's nutty. But I use guessing to actually try to see if I get the right answer. And now we're using guessing to make sure, like, you know, was this the right answer? I think it was. My logic was pretty good on that. Let me see. This was 30. That was 30 because it's 45. And the runner's going in 1/10 of a second. It's going 0.2 meters. And so the angle shifts 0.2. And we just do that. We knew that this was 30. So we now know our new code. We now know this angle, which is 29.8 meters. But this didn't change. That's still 30. And then we can use inverse tangent of 30 divided by 29.8. And inverse tangent of 30 divided by 29.8. And we get, and then we get the degree change. So it went from 45 to 45.19. You know what I mean? In 1/10 of a second. So minus 45. So it's that degree change divided by 0.1. It's a 1.19 degree change. So hell yeah. So that was real fast. But our guess is real poor. Even just calling this a circle. That's interesting. You would think it would be better. But it's not. But anyway, so now 6.28 divided by alpha t, or 2 pi divided by alpha t, and we get radians is 0.047 radians per second. So our guess is that, and our actual answer is 0.033 radians per second, 1.9 degrees per second. It's real slow. But basically, like I said, if the runner was running a full circle, you know, if right here at 45 degrees, instead of running this way, you know, he just decided to run that way around a full circle, you know, at 42 meter radius, well, it's going to take him 133 seconds. So you're literally going to stand there with the camera for about over 2 minutes. You know, it's going to take you 2 minutes to turn a full circle just to watch a runner running in a circle. But this runner's not running in a circle. He's running in a straight line, so it's going to be a little faster. Had this runner just stopped right there at 45 degrees and just started running this way, well, you wouldn't have to change the camera at all. And so this is using the extremes. And if the runner started running this way, well, you wouldn't have to change the camera at all. But if he's running completely tangent, well, then you're going to have to change the camera faster. Oh, that did not make my point easier. Okay, that's interesting. But yeah. So that, oh dang. So our guess should have worked. Honestly, our guess should have worked of saying if this was our circle, you know what I mean? We know this radius, and then we know our circle. And we're going, why didn't that work? Do I have enough time to double check that? Hell yeah. We're going to double check that guess because this is insane. Our guess should have worked. Our guess of saying if this runner's at a 45 degree angle right there, we know this distance because the track's 30 meters away. And if I'm measuring a 45 degree angle, this is 30 meters, and we already found that, yeah, 42.2 was the 30 squared plus 30 squared, square root of all that. That's that h. That's the radius. Oh man! And the circumference of the circle is 2 pi r, which is 2 pi h, which is 2 pi times 42.2. And we said we stored x as 42, and then times 2 times pi. So yeah, that's the circumference of the circle, and that's the distance, 266 meters. Now, if you're dividing by, 2 meters per second, seconds go upstairs, meters goes away, and we find the time it takes to do a full circle. And that's 266. Well, I'm going to store that as u. So alpha u divided by 2, store that as alpha t. We already stored that as t. Okay, so that's the time it takes. And we're saying we want to know angular velocity, which is like radians per second, which is like degrees per second. Well, it's going to take 360 degrees in 133 seconds. So doesn't that, if it took 360 degrees in 360 seconds, well, that would be 1 degree per second. But we're going to get something 360 divided by alpha t, 2.7. Yeah, like I said, that's a little bit higher. So yeah, I don't know why. I don't know using my little logic. I swear I must have set up the trigonometry wrong. So I'm usually pretty good at that, and I got too much script. I would say actually, so I would choose this as my answer. Because if, like I said, if it's running this way or this way, it's going to be slower. Oh, no, that makes sense. Yeah, if it's running a tangent, yes, we said this is going to be the fastest. Yeah, this is going to be the fastest. You're going to have to move the camera. But if it's running towards us, you'll have to move the camera slower. So, yes, maybe that proves that, yes, this is a smaller number. So, yes, this is the actual, and this is the theoretical if we decided the runner just started running in a circle. But the runner's kind of like he's running at us, where, yeah, I'm not going to have to move the camera. And if the runner was right here, yes, this is perpendicular. Because now let's do this one. Oh, this gives, okay, yeah. This is amazing. I'm going to turn off the camera. Okay, we're back. We're back. Okay, we need a second guess. We need to pretend the runner is right here. Now our circumference of this circle is 2 pi r. This distance is 30 meters. So our radius is 30 meters. 2 pi, we don't even need to use pi anymore because I'm super confident about this, but we'll go 2 pi, 2 pi times 30. Perfect. This is 188. So if the runner's right here, yes, this circle, you know, of right there would be smaller, and it would be 188 meters. And if you multiply by, you know, divide by 2 meters per second. See how I did that? So if it's 2 meters per, this second pops upstairs, meters cancel, and you're going to go divided by 2. Perfect. That's going to be our new time. We're going to do alpha y. Y is the time. And excellent. And now you're going to have 360 degrees in that y time, which is 360 degrees in 94 seconds. Oh, that's going to make it even faster. Damn it. No, it is not what we wanted. Interesting. This is very fascinating problem. So yes, 360 divided by y, that's going to be even a bigger number. Okay, but I think we figured it out. If the circle is this big and the runner decides to run in a circle, that'll be the fastest angle change, and that angle change was, we guessed it was 2.7 degrees per second, which was 0.047 radians per second. But the actual, you know, the runner was basically kind of running towards the viewer, or like even just running away from the viewer, but not running tangent, so it's going to be a little bit smaller. Man, I got to throw in the towel on this. And okay, I'm going to go to the internet where we're going to look at what the hell the answer was.
All right, I can't use the volume on these videos. All right, so here we go. I can't use the volume on these videos because you know me. You can't even. I don't even know if you can actually see the picture. But all we want is the answer in the end. That's all we want. So what? We got to watch another commercial. At least it's a beer commercial. All right, so yeah, we just want the answer. We just want the answer. Come on, give it to us. 0.033 radians per second. Hell yeah. So we did it. We did it. Heck yes. And what was our answer? It was 0.033 radians per second. But our guess on this one, our guess did not help us. I mean, we kind of just threw out a guess, but I'm glad we did it. You know what I mean? I think you see my cursor. Yeah, we threw out a guess of just saying this runner was running in a circle. But yes, if the runner took off instantly in a circle, you would have to move the camera faster. If the runner's running towards the camera, you have to move it slower. If the runner's running away from the camera, so that was pretty cool. So I would say the take-home points were like, yes, we did give a guess. It wasn't accurate worth a damn, But we learned how if the runner runs away from the camera or towards the camera, well, shoot, you don't have to move the camera at all. But if the runner decides to run in a circle, tangent to where you're filming, yes, then you're gonna have to move that would be the fastest you'd have to move, and we figured that number out. And sure, this is just a little bit slower than that. So heck yes, we did it. I'm satisfied. We will do a better job. That's how I end these videos, just by saying, you know what? I think we'll do a better job. You know what I mean? In the future. But anyway, I hope you enjoyed this one. And guess what? That's a video.